We now set up the core part of the drone, which is the Pixhawk flight controller. Note the direction of Pixhawk when you attach it. After firmly attaching, now plug the 4 wires from ESC following the figure. Time to mount telemetry, GPS module, and RC receiver. And just fix the receiver, as it is nothing but a buzzer for me. Let's turn on the Pixhawk by plugging USB. You should hear a welcoming sound from GPS receiver. Also, check the status of RC. Green light. As the core part seems okay, you may proceed to install the legs. Looks good. Now warm up your arms and wrists, as we have to do a calibration of the sensors in Pixhawk. The calibration of the Pixhawk is performed on Q-ground control. Download it on the computer. Open it up and connect the computer with Pixhawk using USB. First, upload the latest firmware. Be patient. Now we select airframe as Quad X. To arm the propellers, we should calibrate the sensors. Compass first. I tried arming and ended up complaining from accelerometer calibration. Let's do another calibration. The legs helped me a lot. Arming denied due to unnecessary pre-flight checks. We will disable 3 checks, which I don't care for my drone setting. First villain, check for USB. Second villain, check for battery for Pixhawk. Last villain, check for safety button. Reboot the vehicle. Round 3. Supply power and let's watch the direction of motors. I found out the bottom 2 motors were rotating in wrong direction, so I will switch their rotations by rewiring the 2 of the 3 wires connecting ESC and motor, as the figure from left to the right. We have to do another soldering, which I really hate. Insulation is really important to block the flow of currents between 2 different wires from ESC. Clean up the wires. Finally, the motors are rotating as the Pixhawk indicates. Okay, so what we built so far is very basic components of this drone. So as you can see here, this guy now has 4 motors, and each motor has ECS here, and ECS is connected to Pixhawk, which is the core part of this flight stack. And the Pixhawk now has 3 input channels, so first of which is Holy Bro telemetry. It can communicate with our laptop used as a ground station. And the second member is this RC receiver, which talks with this guy. And the last member is a GPS receiver, from which we can localize this drone when we go outside. So however, in my case, this drone will be used mainly for indoor flight. So for that, so we will instead use this tracking camera to obtain the visual odometry information. And that information will be fused with the various sensors inside of this Pixhawk to obtain state estimation. And based on that state estimation, we can control this drone for our own purpose. And now it's time to make this drone codable in C++ language and ROS protocol. And for that purpose, it's now time to attach this onboard computer on top of this guy like this. So let's move on to the second chapter.